I really don't care about
these two segments, we're going to connect D to E. Everyone's is going to look different because your points are all different, but we're still going to see the same relationship between sides. Now we're going to learn today that this is called a mid-segment of a triangle. It's a segment that connects the midpoints. That's what our lesson's about today. But we're going to understand what the theorem is and why it exists based on using numbers in our own pictures. So the next thing asks us to find the length of AC. If you scroll down, no, where am I? Here, measure. Okay, if you want to find the measure of something, you can click the middle one that says centimeters with line. Now there's a couple ways you can do it. You can actually just go click the line itself. So if you want to find the measure of AC, you can hover your cursor right over like the middle of it, click it, and it'll tell you mine's 5.5. So on your paper, write down whatever yours is on AC. Mine happens to be 5.5. Go find the length of DE. .8. I'm going to go to this one. You should be noticing the relationship between the sides. I don't know if I did something wrong on that. What do you guys notice about the relationship between the side lengths? If I had 3.2 and 6.4. Maddie? Yes. The bottom length will be double the length of the originals. Is anyone doing what mine's doing where it's not exactly the right numbers? I wonder what I did wrong. Let me find my midpoints again. So you want to write down that. You could also say that it's half the length. Yours wrong too. It might be a rounding error because it's rounding to the nearest tenth. Your triangle can be any shape. Okay, if yours is not exact, go take your go back and click your cursor. I think it's a rounding error because it's rounding to the nearest tenth for us, and it may be like something different. You can move these points. Well, let's move these. And move it so that it makes the right number. We're having a rounding problem here. You can take the cursors, once you click the cursor, you can move these. So now see 2.3 times 2 would get me 4.6. Or half of 4.6 would get me 2.3. Okay. So what you want to write on your paper is that you should notice that the mid-segment is half the length of the third side. Or you could say the third side is double the length of the mid-segment. So you can either half it or double it. Of course, when I do an activity, but we found our mistake. Rounding. Okay. Now let's go back. We want to find the measure of angle A and the measure of angle BDE. Okay, to find the measure of an angle, you want to click this first one, and it'll tell you you need to select 3 points to trace your angle, just like we would name an angle. So to find the measure of angle A, we will have to select like either B or D first. So D, A, C. Mine comes out to be 89.1. To find the measure of angle BDE, you're going to trace B, D, E. You should notice that they are the same. Okay, if you want, you could find the other angles also. You could find and prove that these are also going to be congruent. and I can see that those are congruent. And this will hold true even if I move my picture around. See how they always end up being the same, no matter what happens here? Okay. What type of angles are these? Maddie? They're corresponding angles. So using a converse theorem, what we would have needed on our quiz yesterday, if corresponding angles are congruent, then what do we know? The lines have to be parallel. Okay. So we would just, you'll write down whatever measurements you had here. I forget what I had. 72 and 72. What do you notice? They're the same. And that would be, if corresponding angles are congruent, then our lines are congruent. Okay. So we have just done a little numerical proof using numbers of the theorem we're about to learn. The triangle midsegment theorem. Okay, we actually don't need our computers anymore, so you guys can log out outside or just close them up. But I'd like you to understand why the theorem exists and see it kind of in play with numbers. We will be using that software a little bit more in Chapter 5 too, so clear. All right, so the definition of a midsegment, as I kind of already introduced, is a segment connecting the midpoints, mid-segment. Make sense? Okay. Now, I have one drawn. Let's maybe draw another triangle here. Technically, you should have markings showing it's a midsegment. This is the midpoint. So that's one midsegment. How many midsegments do you think would be in every triangle, would be possible? This is one. Right?
3.
3, very good. So if you draw the midpoint on the third side, you could connect this with this, which would give me a second midsegment. And you could also connect this with this, which would give me a third midsegment. So it's like a little triangle inside a triangle. All right, so the triangle midsegment theorem says if a segment joins the midpoint, and let's go ahead and mark that, of two sides, then the segment will be parallel to the third side. We proved that using our converse theorem of the corresponding angles postulate. And the segment will be, this segment will be 1/2 the length of the third side. So in this specific picture, we would say that segment MN is parallel to AB. And then there's two equations you can write, whether you're finding this side or finding this side, and it's all related to doubling and halving. So AB would be equal to 2 times MN. Twice of this number will give me this number. So 2 times MN. Twice of the small segment will give me the larger segment. Now, if you want to find the smaller segment, what do you think that would be equal to? This would be equal to, right?
Do you need like to put 2 times the measure of MN, or you have to?
Usually we don't have these bars. These actually shouldn't be here. For measure, we only do that with angles. So usually when we do segments, we just take the bar off, and that stands for distance. That was actually a typo. But if this is twice this, what would this be equal to? Joseph?
1/2 AB.
Good, 1/2 AB. Okay, so you're basically doubling and halving. Most of this will be mental for the majority of you. Some students struggle with this section. I don't know why, so I added more examples this year than in years past. Some of you will just get it really quick. A couple students will struggle. So always think about, like, 2 times the small gets me the large, 1/2 of the large gets me the small, whenever you're looking at it. We would also have angle A is congruent to angle CMN. Angle B would be congruent to angle CNN. Okay, and that's because of the corresponding angles postulate, since we know they're Some of these will require no work, you're just doubling and halving in your head. If you want to write work, you can. Some of them will have algebra, or you'll have to solve for x. So the first thing you'd want to notice about this picture is that we do have a midpoint and a midpoint, which means that this is a mid-segment. And using the mid-segment formula, or theorem, excuse me, you might want to go ahead and mark. If it's a mid-segment, then it has to be parallel, and we know that it would be half the length of the third side. So the first question asks me, what's the measure of angle VUZ? What would the measure of this angle be, and why? 65. And that's because we know they're parallel, therefore they have to be congruent. The theorem tells us they're parallel, so we're using the regular theorem. What would the length of UV be? Length of UV. It'll be a decimal. Gail? 7.5. It's 1/2 of 15, or 15 divided by 2. How about VZ? Gail? 10. By markings, these are congruent, so this has to also be 10. How big is YZ then? Luke? 20. This example asks us to draw the mid-segments and name all of them. So we would have segment AB is a mid-segment, segment AC, and BC. Remember, the order doesn't matter, so if you say BA, that's the same thing. And then, who can give me one pair of parallel segments? Because we know the mid-segment is always parallel to the third side. Maddie? Say again? BF? Those are parallel? Remember, parallel has to be never intersect. Marquise?
The segment ED, the segment BF.
ED? So
No, EB.
EB is what? I'm looking for parallel, not
Oh.
congruent.
Segment AB is concurrent to segment BF.
Good. The mid-segment AB has to be parallel to the third side, which is DF. That's usually the easiest one to see. Mid-segment and the third side. Now we have two other pairs. Fred?
Segment ED is parallel to segment
EB to what?
ED to BC.
Oh, thank you. Yes. So that was this one and this one. Last one, Kale?
Segment AC is parallel to segment BF.
Very good. So this one and this one. All right, the rest of them on this page are pretty simple. Well, I should say these two. Find the length of DF. What would it have to be?
18.
18. Remember, you double to find the third side. Now, if I give you the third side, we want to find what is the length of PQ. What would that have to be, Justin? 15. 30 divided by 2 is 15. This 32 is extraneous. It's there to trick you. You don't need it. Okay, so you want to make sure you look at the mid-segment and the third side. So when you go up here you're actually dividing by 2, taking a half. All right, now these have algebra in them, so we're going to have to write an equation. The easiest way to do it is to double the small side, because most of you don't like fractions, therefore you don't like doing halves. Okay? So the easiest thing to do would be to say that WY equals twice the value of QR. So the third side equals twice the length of the midsegment. And then plug in your values. You also can do half. Brett, what were you going to say?
I was just making an equation.
Okay, go ahead.
X plus 9 equals 2 times the quantity, 2x minus 3.
Perfect. You do want to make sure you do what he said, which is the quantity. You want to use parentheses around the binomial so that you remember to distribute. And then you just solve algebraically. Get your variables on one side. Get your numbers on the other side. We should get 5. If you want to check your answer, you could plug 5 back in and verify that the lengths are indeed half and twice of each other. But it didn't ask us to do that. See if you guys can try B on your own. That's the equation I would have written. You also could write the equation x plus 19 equals 1/2 of x plus 29. But again, you're going to end up getting halves and fractions slash decimals. Then you should just distribute and solve. What do we end up getting for x? Keys? Should be getting -9. Again, don't think that you did the problem wrong because you got a negative. When you plug -9 back in, -9 plus 19 would still get us a positive 10. So it's not giving you a negative side length. All right, the next page we do have one more example together and then a closure. You will see some of these multi-part questions on your homework. First of all, you do want to read the first statement, which says, the perimeter of triangle MNP is 60. Okay, that's going to be necessary in the problem at some point. Part A asks us find the length of MN. And those of you that like colors, you might like colors on this section. So that you can say that MN, oops. And you could highlight the mid-segment and the third side because then you can visually see the relationship. How big would MN have to be? Yeah? 24. MN is a mid-segment. It has to be equal to 1/2 of XZ. So what we did was 1/2 times 48 to get 24. Technically 24 meters. And you definitely want to make sure you write your answers in the picture because you might be using those in Part B or Part C. So Part B asks me to find the length of PN. So I'm going to pick a different color. PN would be related to XY. The problem is I don't know what XY is. So I can't use like the doubling or halving formulas. What could I use to find this answer? Right?
If the perimeter is 60.
Good. If the perimeter is 60, then I know that all 3 of these sides have to add up to 60. So 24 plus 22 plus whatever PN is, that has to equal 60. You're just subtracting. If you want to add them first and then subtract, you can. And these are all, we should have bars on top of these, but, and we should get 14 meters. Again, as soon as you get that answer, put it back in your picture. You might need that for the last answer. Find the length of XY. So what would the length of XY have to be? Length of XY. Kale? Good. The third side has to be twice the length of the midsegment. So 14 times 2 is 28. 8 years. Go ahead and try the closure.
Don't touch my stuff.